the assumption in this class is that you have seen scientific notation before and you know how to use it, but perhaps you just need a quick refresher, and that's something that we can do. With the addition of this part about significant figures. Okay, so one thing that you need to know is that when you take a number that is written in standard notation and put it into scientific notation, all sig figs are preserved. In a way, this kind of makes this really handy because any numbers that are listed in the base number right here, not the multiplier, we don't worry about the multiplier, these are all automatically significant. Okay, so this says that there are 3 sig figs. Well, here they are. 1, 2, 3. Okay, here it says there are 4. 1, 2, 3, 4. Right off the bat, we can figure this out as well. 1, 2, 3. So there would be 3 sig figs in that number. All right. With standard notation, you need to apply your rules and double check. Remember, if you have a non-zero integer, so any numbers 1 through 9 are all significant. If you have a 0, you need to check your rules. All right, and that's what we'll go into more following this. So the main skill here is making sure that you can go between standard and scientific notation. So remember that when we write something in scientific notation, remember that you can only have one non-zero integer in front of the decimal place. You may or may not have something here. Okay, it might be blank. You might have many numbers. And then n up here, this is your multiplier, your exponent. That's what I should say, is just exponent. Okay, and that tells you how big the number is. So for 600, all right, our decimal place is right here. I would have to jump that twice to get it such that there's only one integer in front of the decimal place. So this would be 6 times 10 to the second power. Now it's 6, not 6.0 or 6.00, because the only sig fig in this number is this 6 right here. So there's one sig fig there, one sig fig there. Going backwards from scientific notation into standard notation, remember that if you have a positive exponent, if the exponent is positive, your number is bigger than 1. Okay, usually if you're bothering to put something into scientific notation, it's usually much bigger than 1. Right? If you have a negative exponent, that means that your number is less than 1, but it's still bigger than 0. Okay, it doesn't make it a negative number, it just makes it a very, very small number. Okay. In order to make one of these numbers negative, you just have to do the normal thing where you put a negative sign out front. That's not what we're talking about right now. So bigger than 1, smaller than 1, but but greater than 0. Very, very small number, usually a very, very big number. It doesn't have to be. That's just a good way to think about it. So if we have a positive exponent like we do here, we're going to have a number that's bigger than 1. So it's to the third power, so that means I need to jump my decimal place 3 times. 1, 2, 3. This would be 6,010. And just double checking that I still have 3 sig figs. 1, 2, 3, there they are. Sweet. Okay. Next, going from standard to scientific notation, here are my sig figs right here. These 3 zeros, these are all placeholders. They are just there to show you how small the number is. Okay. So in my final scientific notation version, I should also have 2 sig figs. So if I just wrote it as 6, that would be 1 sig fig. I have to write 6.0 times 10 to the, and that would be negative 1, 2, 3. Right? Negative exponent because my number is smaller than 1. Here's another smaller than 1 number. Okay, here are my 3 sig figs. I need to make sure that all those are preserved. I'm going to jump my decimal 3 times. 1, 2, 3. Always have your leading 0. So 0 point, and then that would be 0, 0, 3, 5. Now I can't stop there. That's only 2 sig figs. I need to include that last 0, this one here. These 3 are your significant figures. This example is largely annoying. In no real life scenario that I can think of would I take this number and put it into scientific notation and think that that was actually useful. But I'm going to do it for you now. These are all significant, right? We've got non-zero integers and then some zeros that are sandwiched, so they're all going to be significant. That means they all need to make it into my scientific notation. So like I said, this is kind of a pain. Here's my decimal place right here. I have to jump it 1, 2, 3, 4 times. So this is going to be 1.0001 times 10 to the 4th power. That's annoying. But now we know how to do it, and that's what's important. Last one, negative exponent, so the number is smaller than 1. I have 4 sig figs, they're all right there. Jump it back twice, 1, 2, so 0, right, leading 0, 0.0165. Have to include that last 0 for my 4 sig figs. And there we go, scientific notation.